Welcome to the Stellantis Tech and AI podcast. I'm Dale Jewett, your host. And in this episode, we're going to talk about hybrids for work and for play, and Stellantis' game-changing approach to this topic. Our guest is Joe Tolkacz, who is the STLA Frame propulsion system chief engineer at Stellantis, and he's got some interesting insight into what we've been doing. Joe, it's nice having you with us today.
Good morning, Dale. Great to be here.
All right. So before we get going, Joe, you've been involved with hybrids for a little bit. How about you give me just a quick overview of how you got into what you're doing?
So I've always been very interested in the technology. I was fortunate enough to get into it about 20 years ago. So maybe not at the very first point that some of the technology is being developed, but pretty soon afterwards. And I've kind of grown along with the industry, and it's been a lot of fun.
All right. So hybrids, I'm not certain even today that many people completely understand what a hybrid propulsion system or a hybrid powertrain is. A Ram brand has recently offered a unique solution that they're calling the Ram Charger, which is a type of plug-in hybrid. Joe, can you just give me a basic overview of how the Ram Charger system differs from what most people might think of as a hybrid?
Sure. So I'd like to talk about electrification in terms of maybe an electrification number line. If you're starting on the far left, there's basic technology, start-stop, which is pretty much in a lot of vehicles now. Our Dodge Durango has it. Many of the other Stellantis products does have it. And then on the other end of the spectrum is the battery electric vehicles. Stellantis has done a Fiat 500, and we have others that more recent, like Dodge Challenger, and also the Wagoneer S. Those are on the other end of the spectrum. The technology on the far left, if you consider that, is affordable, but doesn't give much electrification. It provides start-stop, no electric drive, not even regen for the extreme case of that. The battery electric vehicles are on the other end of it. They eliminated the engine, a very simple drive system. You don't have maintenance costs of an engine. You don't have the challenge of finding a gasoline station, filling up, maybe spilling fuel on your pants, that type of thing. The Ram Charger, we believe, does the best, I'll say, optimization of maybe the benefits of the battery electric vehicle, as well as some of the benefits of a more conventional vehicle. For instance, we're targeting about 140 miles of range electrically. Most people's drive, we've done data analysis on this, and I think about 90% of the drives typically in a day are 100 miles or less. So, you can kind of anticipate the battery for most drivers, a very high percentage of the drivers, they could be driving all their drive time all electrically. For those of us who like driving farther, if we have cottages or driving cross country on vacation possibly, and don't have to deal with the time involved in charging up the battery, we have the generator that's able to charge the vehicle as you drive and charge the battery as you drive. So, you get maximum flexibility as a customer. You can choose to drive electrically if that's your use model. And, if you have to tow a long distance, for instance, we cover you that in that regard as well.
That's cool, Joe. Now, here's what I think is a unique thing. In most parts of the world, when you look at what an electric vehicle is, they tend to be cars. Here in the United States and in North America, our vehicles are larger, and we are definitely a truck and SUV region of the world. There have been electric trucks. There are electric trucks on the market today. And I think one of the big concerns that people tend to have if they experience this, what if I use my truck for work? Or what if I need to take my boat to the lake? The reality is, when you load a truck with a trailer hitch or something, range becomes a real issue. The stated range goes way, way down. I think this is a big reason that sort of led us toward the Ram and the Ram charger system, because as people debate whether they want more electrification in their vehicles, range is still far and away the number one issue for people. You'd mentioned 140 miles on the battery pack for the Ram charger, which is nice, but that's probably not going to work for somebody who lives in Nebraska and needs to cover that distance. So I think this unique solution. So what happens to the Ram charger when the battery pack reaches its minimum state of charge?
Yeah, that's a great question. And we typically start out in what we call charge depletion. And so we're going to be using up the battery energy. As we use the battery energy down to the minimum state, as you said, the generator turns on, and the customer actually does not feel it because of the way we've designed the architecture. And we can continue on his trip. And when you combine the electric range with the range out of the gas tank, we're targeting about 690 miles. So, if the customer is capable of sitting in a car that long, we can drive all day without having to stop.
Now that is an impressive number for certain. And I'm sure if you're going to use the truck for work or if you're going to tow, that total range may come down a little bit. But from what I understand, when your range is depleted, it's still a matter of finding a gas station and filling up the fuel tank, as opposed to necessarily finding a charge point and waiting, I guess, it could be up to an hour or so for the battery pack to charge up.
Yeah, that's a great point. Typically, most people are in gas stations. They're in and out in a couple minutes. Maybe they grab a coffee and they're on their way. The chargers, they've come a long, long way from when we started in the industry. But even with DC fast chargers, when you talk about the size of the battery like we have, which is 92 kilowatt hours, you're still looking at 45 minutes to an hour, best case, to be able to charge that. So, if people are in a hurry and want the convenience of a gasoline vehicle, we believe the Ram charger fills that need, as well as providing the customer a benefit of being able to drive electrically, which will lower his overall cost of ownership.
Okay. So if you don't mind, let's go through the Ram charger system in a sort of component by component way to get a real understanding of how exactly all of these units are working together to make this possible. And unlike a normal thing, I think I want to work backward on this system. So I'm not going to start at the front of the truck. I want to start at the back of the truck, which is where you have the electric drive modules, which we call them because they not only just have an electric motor in them, but they tend to integrate any kind of a gear reduction, and they integrate some controllers in there. So in our trucks, in the Ram charger system, is there only a drive module in the back? Do we put a drive module in the front? How do we manage those?
Yeah, we have a drive module in the back and we have one in the front. Both of them have, as you said, a 3-in-1 system where there's a motor, gearing, and a power electronics module. The one in the back has also the capability, if someone chooses, to add what we call an e-locker. So this is essentially the electronic equivalent of a locking differential. So for those guys that want to go off-road and climb over rocks, we're providing that capability. The one in the front is very similar, does not have the e-locker, but it has what we call a wheel end disconnect, so that we can drive completely off the rear if needed, and that's a higher efficiency mode. But in the case where, because of environmental conditions like snow and ice or traction needs, we can turn that on and we can go into 4-wheel drive mode as well. So pretty versatile system. We feel it can basically cover any driving scenario a customer may encounter.
Interesting. So in my day-to-day, if I have a Ram charger and I just jump into the vehicle, is it always operating in all-wheel drive until I tell it otherwise, or is there a more efficient strategy?
Yeah, we have a lot of electronics and a lot of control strategies built into the vehicle. The typical operation is going to be the driver selects auto mode, And you're going to launch in four-wheel drive mode because that provides the best traction. And then at some speed, we're still trying to tailor this a bit as we tune the vehicle, but somewhere between 10 miles an hour and 18 miles an hour, we expect if it's under light driving, city driving, we'll disconnect the front axle and drive rear-wheel drive only. And that's, light driving, the kind of thing you would do in the city or highway cruising type of environment. Then if the driver steps in and is accelerating very hard, we'll re-engage the front axle and you'll have the capability of both the front and the rear electric drive modules.
And we've talked about with Ram Charger, this thing is geared for work. Some of our Ram customers really work their trucks. So if I put a load on the thing, we've talked about up to 14,000 pounds of towing capacity in this truck. Do the EDMs, do they react differently? Do they have to do something special to be able to manage that level of work?
The EDMs are designed for that work customer. So there's nothing special that has to be done, no special maintenance. Just hook up your trailer and you're off. Typically, we've done a lot of testing on this. We've done a lot of analysis before we did testing, and we're quite comfortable. You can tow cross country 65, 75 miles an hour pulling that 14,000 pound trailer. You mentioned Nebraska, that's a good use case, pulling that trailer across, I think it's I-80 up there, and you can do that all day long.
That's great. All right. So if we move on from the EDMs, now we need electricity, right? So I think that takes us to the battery. Where is the battery pack mounted for this system, and what type of battery are we using?
So the battery is mounted on the bottom of the vehicle as part of the frame, and as part of that, because we wanted to package as much battery as possible, the STLA Frame architecture has kind of a unique feature. On most pickup trucks, the rails are pretty close together. We were able to pull those out so that we can maximize the amount of battery as well as run, the engine and generator plus the exhaust system and the fuel tank back there. So getting to the battery, it's a 92 kilowatt hour battery installed energy, and it's lithium ion is a cell technology, and it's nickel manganese cobalt cathode type technology. So pretty high tech stuff. The design is very modular. We have what we call modules that have what's called the 8S2P, the cells in that configuration. 8S meaning there's 8 in series, so one after the other, and then the 2P is two strings that are in parallel, and that's what we believe the best trade-off between torque that would be delivered versus energy to drive the vehicle. So in these modules, there's 12 of them, and if you look at them closely, they look like shoe boxes, and you were able to stack them up very well, connect them up with bus bars, and they are very efficient in how they operate.
Okay. Does the battery pack charge mainly from the generator in this system, or do you need to plug it in?
There's flexibility to do both. So we can charge it from the gen set, which is the combination of engine and the generator. The customer also has the flexibility to plug it in, and we have 3 levels of charge capability. You have the level 1, which is 110, so no special charger needed. If you can find an outlet, you can charge your Ram charger. We also have level 2, which is a 240 volt level of charge. And then level 3, which is called DC fast charging, and that's the one where you can add about 5 miles per minute of range using the DC fast charger.
Okay. All right. So then moving on from the battery, you mentioned this thing called the gen set. Tell me, what is the gen set?
So the analogy I like to use is for the folks that have a backup generator in their home, they actually have a gen set. They have a small motor, electric gasoline engine typically, or propane or something like that, as well as a generator. The engine basically takes energy or from thermally, it converts fuel of some kind into mechanical energy. And then the engine converts the generator, I'm sorry, converts that mechanical energy into electrical energy. And basically, we have the capability to put that to the battery. So when we use the term opportunity charge, for instance, if you're driving down the road and it's a pretty light load, but we see an opportunity to charge that battery by running at a more efficient point. We may position the engine slightly higher load that the customer wouldn't perceive, but we can take advantage of a more efficient operating point, store energy in the battery for use when you might be in a condition where operating the vehicle would be less efficient, and then you can pull that energy out of the battery. So that's how we get that really great range doing that type of strategy.
Interesting. So here I think is an important question that a lot of people would have. Knowing that there's an engine, in this case, a V6 engine that turns the generator, is there any time that V6 engine is actually driving the wheels?
No, there's no mechanical linkage between our gasoline engine and the wheels. Some of the other technologies out there that have claimed they did not have a mechanical linkage actually did. We truly have the engine disconnected. There's no mechanical link to the wheels from our engine or generator.
Okay, so that means the only way to turn the wheels is electricity. Does that electricity have to flow through the battery first, or can you go directly from the generator to the wheel?
Yeah, you can go directly from the generator. We have what we call power looping, where basically you don't need to put it into the battery to the wheels. You can basically drive EDMs from the generator. So you'd have essentially one electric motor driving the other two electric motors if you're in the four-wheel drive configuration.
I haven't had the chance to drive this yet, and part of that is because we're still preparing the vehicle. But what's it sound like? When I get in the vehicle and I push the start button, does the engine start up right away? Or when does the engine actually run, and do I actually hear it?
So when we start up, you push the start button and we do what's called a silent start. So we go into a propulsion ready mode. The engine doesn't come on, and even in what we call charge sustaining mode, your initial launch will be electric. If you get deeper into that launch, deeper into the accelerator pedal, if you're in charge depletion mode, you'll still stay with the engine off. When you're in charge sustaining mode, depending on the state of charge, is likely the engine would turn on, especially during heavy accelerations. Will the engine stay on? Most likely it'll cycle, and that's the beauty of our architecture. We have what's called a series architecture. So the engine is not coupled to the wheel, so any disturbance when the engine comes on, we can mask that out from the driver experience. So we feel that's a big advantage of this architecture. In terms of the quietness of the engine is very quiet. We've talked in the past about we've played a little game with some of our leadership. We put them in the vehicle and ask them, tell us when the engine's on, because we don't have a tach in the vehicle. And more often than not, they get it wrong. And they think the engine is off and we had the engine on the whole time. So we're still working to refine that some more. We think we have a little bit more tuning to do, but the vehicle is very quiet. If the customer likes that aspect of a battery electric, the quietness of cruising through your neighborhood, they'll have that experience with this vehicle as well.
Well, Joe, it's probably good for your and my careers that we're not naming names in the "is it running" game. Here's a question: since the engine's only job is to turn the generator, how do we decide what's the right size engine?
Yeah, that's a great question, and I get that a lot. I'm a firm believer in, I think it was Einstein's statement, that the best solution is the simplest one that works. And I'd like to add, if I can be so bold, a Tolkacz corollary, which is the best solution is the simplest one that meets the requirements. And we basically started from the requirements. We've had a lot of data from our customers. We know how they use the vehicle. They know the use model. The Ram customer, they want a tough truck. They don't want, something else. They want to be able to tow. A lot of our guys are using these as work trucks. They play in them. So it's got to be capable. And so we looked at what the capability needs were. from the towing perspective and work backwards from that. What we determined was based on the different drive cycles and all the tests that we run, we knew we needed something in the area of 180 to 190 kilowatts capability. So that size the generator, we actually went a little bit above that. We can do 202 kilowatts. And then we looked at, okay, what engine is needed to match up with that? And we found that the Pentastar was almost a perfect match. It generates right around 202 kilowatts itself. So it's stable technology. We didn't need to add a lot of cost on the engine side, like adding turbochargers or anything like that would add complexity and cost. And we also felt the Pentastar is a very quiet engine. It would enhance that BEV type of feel. And it was, like I said, it was the best solution, the simplest solution that worked for us.
All right. And from an engine standpoint, using it like this, does that change like the maintenance demands for an engine? Are oil changes, do you still have to do oil changes? I'm guessing you do, but I don't know how often.
Yeah, that's a great point. You actually decrease the maintenance intervals on the engine. So if you're used to getting an oil change every 7,500 miles, you'll go much longer. And I can't really give you a completely accurate number, but it'll be probably in the area of 10,000 miles or so, depending on what your personal drive cycle is like. I think based on how I drive, I would expect it to be, somewhere north of 10,000 miles before I'd have to change the oil.
All right. So that's interesting. That's pretty much the layout of the Ram Charger propulsion system. Now you told me that the gen set, the engine and the generator, they're a lot like a backup generator that a lot of people would have at their house. Can I use this as a backup generator?
Yeah, that's what we feel, a huge advantage of this vehicle is. We have a couple of different what we call V to X modes or vehicle to something modes. Let's start in the rear of the vehicle. We have what's called V to load or V to L, also more colloquially known as a power panel. We have two levels of power capability. One is 3.6 kilowatts, and it can provide two 20 amp outlets, just like your house. And then for those guys driving, want to run circular saws, 240-volt circular saws, we have a 240 twist lock connector on our up level power panel. So in that 7.2 kilowatt power panel, we have two 20 amp 110 outlets, as well as that 240 twist lock connector. So a lot of capability there. So that's in the rear of the vehicle. We also have capability to do what we call a Vita Home feature. We're working with a couple of different suppliers that follow the SAE spec for that, for Vita Home. And, I think it's, I live in Michigan. We lose power during ice storms and other things. A lot of my friends have Generac generators that use them once or twice a year, and the rest of the year they sit. If they have one of these vehicles, that's kind of a built-in capability that comes free with the vehicle. And the third piece I'd like to talk about is vehicle to vehicle through a charging cable. It's basically the equivalent of a high voltage jump start. So a battery electric vehicle that had supreme range anxiety, that didn't quite make it to the next charging station, stuck by the side of the road, you can come along and donate some electrons. And we think that would be a really good case for people like AAA that would buy these trucks to be able to provide that road service capability. So we think there's a lot of really great features over and above just the driving aspects of this vehicle.
Interesting. I could see if you own a Ram Charger and there's a power outage, you might be the most popular person in your neighborhood, at least with your neighbors.
Yeah, we've done some studies on that, and depending on the usage of your neighbors, if I think we were thinking somewhere between 13 and 25 refrigerators you could run. Everybody could keep their frozen goods solid until the power comes back on. So, and that's the beauty of having the gas tank. As long as you're able to refill it, you don't deplete your charge down to the point where you can't power those refrigerators.
That's pretty slick. This system just amazes me. I think here it is. It's a package that offers you a lot of the benefits of electric propulsion, You get a lot of instant torque. The driving method is really nice. You push the pedal and it goes. By the way, what happens when you push the pedal? Do you hear the engine rev up and down at all, or is it just pure electric joy?
So in charge depletion mode, you're going to start out electric. And as I mentioned, charge sustaining, you'll most likely start out electric. When the engine comes on, we have what we're called pedal follower and design into our system. So we want the engine to be intuitive. For that customer that's used to when they press on the accelerator pedal, it would accelerate and engine would flare and then step back down as you go through the various gear shifts. We want the behavior to be similar to that because we feel that's intuitive to the driver. Some of the hybrids out there, some of the ones you mentioned earlier in the podcast, have what I would call less than intuitive control of the engine. They're constantly hunting for the best optimal point because they're all about fuel economy. And that actually creates some uniqueness such that the engine will change speed and tone without a driver input. We felt that was not a very pleasant experience. We've gotten feedback from some of the competitive data we have that customers don't like that. They want the engine to respond when they do something basically on their command. So we've designed it that way to make it intuitive, and we think the person coming out of a more conventional vehicle will agree that the behavior is intuitive.
Okay. This system is interesting. Could you use it for bigger vehicles or smaller vehicles? Or is this really specific to a truck type environment?
We've designed the system to be scalable. We're looking at scaling it up and we're looking at scaling it down.
All right. Joe, this seems like you must have a lot of fun every day. Uh, if I'm an engineer or if I'm an engineering student and I'd love to work on what you do, what advice might you give me as to how could I end up in doing the kind of work that you've been doing?
Yeah, that's a great question. And I'm a big believer in doing stuff outside of the classroom that supports what you learn in the classroom. And I think, even at the middle school level, there's a lot of great robotics programs. I think there's things like Science Olympiad that reinforces what you learn in the classroom. A lot of times when you're taking the math and science, it's difficult to see the application. I think those activities outside the classroom, and if you're fortunate enough to bring them into the classroom, I think that really cements it. I know it did for me. I was always the person that was kind of lost in lecture until I got to the lab and could, feel and touch and understand, oh, that's what it means when they talk about current, and that's what it means when you talk about voltage. So I'm a big believer in getting involved in those outside activities. At the college level, there's a lot of great activities that we've partnered with the SAE level. Stellantis has a great activity right now called the Battery Challenge. Great activity for the universities to design a battery to go in one of our Stellantis products. I would encourage engineering students, if you're not already involved in that, to get involved in that if that's your career interest field. So those are some of the things I would look for. The hands-on type activities to reinforce what you learn in the classroom.
Yeah, there's nothing quite like bashing your thumb on something to make you remember an important lesson, right?
Yep.
I've been there before. Joe, this has been a great conversation. I really look forward to the chance, hopefully soon, that we can get together and you'll let me jump into one of your trucks and we'll just take off and drive it like normal, because it seems to me, for all the advanced technology that you're building into this Ram Charger, it's a no-brainer for someone who just wants to drive the truck. So I look forward to that.
Yeah, it's a great experience. I'm fortunate enough to be able to get them on a regular basis, but I can't wait till I have a production one in my driveway.
All right. Well, thank you, Joe, for your time and your thoughts in this great conversation. I appreciate that. And I want to thank everyone else for listening to the Stellantis Tech and AI podcast, where we speak with some of the brightest minds in the tech and automotive industries, like Joe Tolkacz. We invite you to follow Stellantis Tech and AI on LinkedIn and Instagram to join the conversation, stay updated on what's ahead, and be a part of the community exploring the fast line of technology and AI in the automotive world. We'll see you again soon.